The kind of bonding that we've been dealing with in the last few clips are bonding like between two F2 molecules. A single bond, because fluorine, neutral fluorine, has just a single bond, 3 lone pairs. And this bond, a bond with 2 electrons over 2 atoms, and 2 center. So the kind of bonds that we've been dealing with are the 2 electron, 2 center bond, or probably more often called the 2 center, 2 electron bond. In this clip, we're going to deal with a new kind of bonding, the 3 center, 4 electron bond. And this new kind of bond will really tie together all kinds of information that we've seen before. VSEPR, the octet rule, resonance, and in the most remarkable way. So, the molecule that we're going to look at is PF5. Then we're going to draw its 3D Lewis structure. Put in chat, where do I begin? 3D Lewis structure of PF5, it's a central atom molecule. Do I start with VSEPR or do I start with formal charges? And the answer is you start with VSEPR. What is the central atom? Put it in chat. What's the central atom? What's the most electropositive atom? And the answer is phosphorus. It's most electropositive. And what is the steric number? I'll give you 10 seconds to work out the steric number. PF5. Phosphorus has 5 valence electrons. Figure out its steric number. Its steric number is 5. Phosphorus has 5 electrons. Each fluorine donates 1 electron. That's 10 electrons divided by 2 is 5. And what's the name of the shape then? There are 5 fluorines attached to the phosphorus. Steric number of 5. Put in chat what the name of the shape is. It's put in chat, trigonal bipyramid. And at this point, what should I draw? And more to the point, what should I not draw? What should I not draw? Put it in chat. Put in chat what you don't draw. We don't draw the bonds. We know where the atoms are located in a trigonal bipyramid, but we don't yet know the bonding. Here, I know my fluorines are in a trigonal bipyramid, 3 equatorial, 2 axial, but we don't yet know their arrangement of the bonding. And already we can see the bonding has got to have a problem, because this molecule is going to obey the octet rule. The octet rule is 4 pairs of electrons. But that phosphorus looks like it's bonded to 5 atoms. It cannot be 5 2-electron, 2-center bonds, because 5 times 2 electrons is 10 electrons. And the octet rule is 8 electrons. So we're not going to be drawing 5 2-center, 2-electron bonds. What we are going to do is use the techniques that we've developed in this lecture. The first technique is to look at formal charges. So, when the octet rule is obeyed, and this molecule will obey the octet rule, because main group atoms which obey the octet rule always obey the octet rule whenever they can. When phosphorus has 3 bonds, what's its formal charge? Put it in chat. When phosphorus has 3 bonds, its formal charge is 0. When phosphorus has 4 bonds, what's its formal charge? Put it in chat. When phosphorus has 4 bonds, it's behaving like silicon. It's +1. If fluorine has 1 bond, what's its formal charge? That's the typical thing for halogen. Its formal charge is 0. And if fluorine has 0 bonds, what's its formal charge? 0 bonds, what's its formal charge? And the answer is -1. And so we're trying to find a sum of the formal charges which adds up to the right numbers and yet makes good sense. And I'm just going to give you the answer because it's so unbelievable. The answer is this. We know the shape is, here's the P. Here we know the fluorines are like this. And we're going to make phosphorus with 4 bonds. That makes it phosphorus. Phosphorus for 1 is plus. And notice I don't write the numbers. If it's 1, it's just plus. That means plus 1. There's the fluorine with no bonds. It's minus 1. I draw my lone pairs so that everyone obeys the octet rule. And there's so many things wrong here. First, it doesn't look like that fluorine in the bottom is bonded. But is there another Lewis structure, a resonance structure? And the answer is yes, there's this resonance structure. So, remember what I said? Atoms don't move in resonance structures. So, half the time, the phosphorus is making a bond to the fluorine on the top. And half the time, it is making one with the fluorine on the bottom. And I'm just going to circle something here. These 3 atoms make. This is the 3-center 4-electron bond. We'll understand why it's 4 electrons as we learn more about orbitals, but I can just tell you one important thing. The 3-center 4-electron bond requires 3 main group atoms in a straight line. 3 bodies in a straight line has that great word in the English language, one of the greatest words in the English language, which I barely know how to pronounce even, syzygy. The best word out there for hangman. Okay, and in the 3-center 4-electron bond, one atom appears. Exactly one atom appears detached in each resonance structure.